Okay, so good morning, everyone, and thank you for joining us. Welcome to this first session in Mosaic Factor's webinar series on explainable AI. Today, we want to keep the conversation practical and very easy to follow. This session is called Explainable AI for Decision Makers, and the idea is to look at AI explainability from a business point of view, not from a purely technical one. At the end of the session, we will leave some time for a Q&A. So if there are any questions coming up during the webinar, please send them through the chat. And Burju, our Chief Data Scientist, will be happy to answer them later. So let us introduce ourselves. So I'm Anna Valli, Product Manager for Explainable AI here at Mosaic Factor. And I'm here with Joan San Pablo, who will present together with me, our head of sales. Joan, I think the best way to start would be by answering, what do we want people to live with today?
Hi, Anna, thank you for the introduction. Well, I think the main goal is that people live with a clear sense of when explainability really matters, why it matters for decision making, and how it helps company use AI with more confidence. We are not trying to turn this into a technical masterclass. What we want is to make the topic understandable for executive and business leaders while still being rigorous enough to be useful.
Exactly. So let's start by placing this session in the wider context of the webinar series. This is the first session in a series that we have created where we will look at explainable AI from different angles. We are starting with decision makers, and later we will go deeper into areas like healthcare, automotive, and manufacturing. We chose to start here because in many companies, the first barrier to AI adoption is not the algorithm. It is trust. Is it comfort? It is where people feel ready to use the AI outputs in real decisions.
Yes, and that is something we see again and again. A model may look impressive on paper, but when it reaches to the business side, the questions change very quickly. People start asking, can I rely on this score, this recommendation, this ranking? If the answer is not clear enough, adoption slows down. And that's exactly where explainability becomes relevant.
So this first session is really about connecting the AI performance with business confidence, right? And this connection is where Mosaic Factor usually brings value, right? Before we go deeper into the topic, let me introduce a bit more from what we do in Mosaic Factor. So we are a boutique AI and big data engineering firm based in Barcelona. And well, this year is special for us because it marks our 10th anniversary. And over that time, we have delivered more than 40 innovation projects and collaborated with more than 35 clients and partners across European ecosystems. And our work spans data analytics, machine learning, AI solutions, digital twins, and increasingly, of course, explainability and trustworthy AI. And we have done that across sectors like mobility, logistics, and automotive, and now also manufacturing and healthcare.
Yes, and what I would add is that we work very much with real world mindset. We are not interested in AI as a lab exercise. We care about how it performs in real operations, with real constraints, real users, and real business consequences. That is also why explainability is such a natural topic for us. If you work close to deployment and adoption, you quickly see that accuracy alone is not enough. And people also need enough visibility to use AI responsibly.
Yeah, exactly. Explainability is not separate from the rest of our capabilities. It builds on a strong data foundation, solid model development, and of course, a clear understanding of business needs. And so let's move into the key question here. Why should executive care about explainable AI?
Well, actually, because the moment AI start influencing decisions that actually matters, explainability stops being a nice extra and become a business issue. At that point, the question is not longer only whether the model performs well. The questions become whether people can use it with enough confidence to act in it responsibly.
And that is where the 5 words on this slide become very practical, right? So it's trust, adoption, risk, supervision, and quality.
Yes, exactly. If users do not trust the output, adoption suffers. If there's not enough visibility, supervisions become weak. And if decisions cannot be justified, risk increases. Also, if no one can challenge the output when needed, decision quality also suffers. So that is why many AI initiatives do not fail because the model is useless. They fail because the organization never become comfortable enough to use the model in a meaningful way. The gap between technical performance and practical trust is exactly where explainability helps. It does not solve everything on its own, but it helps people move from curiosity to confident use.
Yeah, and that is a good bridge actually to the next slide, because before we talk about explainability, we should align on what we mean by AI in the first place. So one thing that happens all the time is that people use the word AI as if it only meant ChatGPT or other generative tools.
Yes, and that is very understandable because those tools are very visible, but AI is broader than that. Artificial intelligence, let's say, is like the broad umbrella. Inside that umbrella, there is machine learning, and that refers to models that learn from data to predict, classify, rank, recommend, or detect patterns. And there's also generative AI, which is about more on to creating content, such as text, code, images, audio, or video. And large language models, LLMs, as we know, are a subset of generative AI. Focuses on language tasks and conversational interfaces.
Well, and the key point for today is that explainability can be relevant across this whole stack, right? But not exactly in the same way. So the questions you ask for a predictive model are different from the questions you ask of an LLM. But in both cases, people still need enough visibility to trust and to supervise the system. Um, let's then define the central concept here. What is explainable AI? And well, just as importantly, what is it not?
Well, I think that the simple way to describe is explainable AI helps translate model behavior into information that people can inspect, challenge, and use. In practical terms, it helps answer questions like why did the model produce this result, what seems to matter most, and what should a human understand before acting on an output. So, explainable AI is really a bridge between technical complexity and human decision making. It helps us understand model behavior, also support validation and monitoring, and make output more usable for business decisions.
Yeah, now the important part also what it is not, right? So it is not a warranty that the model is correct. It is not a replacement for governance, for testing, for controls, or for human oversight, right? So it is not proof of causality or a direct window into the model's true inner reasoning.
Yeah, that last point matters actually a lot because sometimes people expect explainability to reveal the full mind of the model. In reality, it gives useful evidence and useful signs, but not an absolute trust.
Yeah, and I think that distinction is actually reassuring because it keeps expectations realistic. So now that we know what explainability is, let's talk about the different levels of transparency and also the access we have to existing AI models.
Yes, well, a useful way to think about this is through black box, gray box, and white box model. Black box models are more whose internal decision process is difficult for human to interpret it directly, while white box models are models that are easy to understand by nature, actually, because their logic is more transparent by design, and gray box model sits somewhere in the middle.
Yeah, and let me just add one nuance that is worth saying is it's not the same whether the code is accessible or not for a company who's trying to explain it and they don't have access to the code or the model because they haven't developed it, right? So that is an important distinction because many people confuse black box in AI with closed software.
Yes, and in practice, the more opaque the model is, the more we may need post-doc explainability methods. The more interpretable the model is, by design for sure, the more the challenge becomes presenting its logic in a way that the user can actually understand. So this is really a trade-off space between interpretability and complexity. And in business, the right choice depends on the use case, the level of risk, and what people need to understand.
Okay, so once we accept that different models have different levels of transparency, the next question is where explainability creates value inside an organization.
Well, we usually group that into three broad areas. The first is compliance and governance. Explainability can help support auditability, evidence of control, decision justification, and human oversight in a sensitive workflow. The second would be development and validation. It helps technical teams understand model behavior better, diagnose errors, identify weakness, and improve reliability over time. And the third, which is really our focus of today's webinar, is decision making. This is where explainability helps turn AI outputs into something people can actually use. It helps create business trust, produce more usable recommendation, and support better informed decisions.
And what I like about this slide is that it shows that explainable AI is not only about regulation, it is also about making AI operationally useful. So Shai is most valuable when AI influences meaningful outcomes, and people still need to challenge and justify or escalate these results. And with this, now let's make that a bit more tangible, let's say, by comparing predictive AI with generative AI and LLMs, because the need for trust exists in both, right? But the practical mechanisms to do that are different.
Yes, exactly. In classic predictive AI, explainability often is about features and predictions. For example, let's imagine a model that predicts which customers are most likely to churn. A business leader may want to know why one segment scored higher than the other, or which factors are driven the risk in a specific case. So, in that kind of system, the questions are often why did the model score the way in this particular case, which variables matter the most, and how stable the model is overall.
Yes, and in LLM systems, the focus shifts. So there, the questions are more about traceability, evaluation, and governance of the full workflow. So for instance, if you have an internal AI assistant answering policy questions, a manager may want to know what sources shape that answer, how the response is validated, how hallucination risk is managed, and when a human review should step in. So in classic machine learning, explainability is often closer to predictions and variables, whereas in LLM systems, the conversation broadens to trust in the whole chain behind the answer.
Yeah, exactly. Some business need trust, but the practical mechanisms for that are different.
Mhm. So at this point, a very natural question would be, how do you actually make explainable AI operational inside a company?
Well, the first principle is simple, is start with decision, not with techniques. Let's say before choosing any explainability method, executives should ask three questions. What business decision is being influenced? What would a wrong answer cost? And who needs the explanation? Is the model owner, the auditor, the operation, or an executive sponsor?
Yeah, I like this because it immediately puts the business context first.
Yes, exactly. Once these answers are clear, you can better judge the level of explainability you actually need. This is why the framework on the slide starts with defining the use case, identifying stakeholders, assessing the risk and the impact, and then choosing the method, validate them, and then monitoring and approving and adopting them over time.
So explainability becomes, let's say, an operating capability and not
Mhm.
just a technical add-on.
Yeah, that's exactly the idea. Yeah.
Right. So once that direction is clear, we would like to show you how we manage the internal workflow around explainability. So at Mosaic Factor, we treat explainability as a structured process, so not a one-off visualization exercise.
Yes, we start by defining the objectives very clearly. What decision is the model supporting, and what kind of understanding is actually needed? Then we identify stakeholders, because developers, compliance team, business users, and executive do not need all the same level of explanation. And after that, we choose the right explainable AI approach and validate for sure whether it is actually useful. And when we say useful, we mean actually reliable enough to trust and good to reflect relevant model behavior, and for sure, actionable enough to support real decisions. Then comes delivery, meaning how the explanation is presented to the user. And finally, we monitor over time, because a system that is useful one day may not be adjusted as the model, the data of the business as it evolves.
Yeah, so it will be adjusted, right? And this also is
Mhm.
where your teams would look not only at outputs, but at data, at model behavior, and check for bias and fairness. But for us, explainable AI has to be connected to this wider quality and governance picture. Okay, so if we bring this together, how do we approach the challenge?
Well, at Mosaic Factor, we use a 360-degree view for model behavior to business-ready explanation. Let's say our goal is to make complex artificial intelligence system more understandable, more governable, easier to adopt, so people can actually use them with confidence. So the first thing we do, we focus on the business perspective. We tie explainability to real decisions, real risks, and real stakeholders. Then, when possible, we prefer models that are interpretable by design, and when that's not the right option, we add the right explainability layer where it creates value. Third, we combine this model insight with validation, oversight, and operational monitoring. And finally, actionability. We turn technical output into explanation that people can actually use.
Yeah, that last point I think is especially important because a technically, let's say, elegant explanation is not enough if the person receiving it still doesn't know what to do with it. So it's not clear for them.
Mhm. Yeah.
So our job is not just to explain the model, but it is to help make AI usable in business reality. And well, let's close with three main ideas we'd like you to take away from today.
Mhm.
First, explainable AI makes AI outputs more usable, trustworthy, and actionable for business teams. Second, not every AI system needs the same level of explainability. And third,
Mhm.
the right explainable AI approach depends on the use case, on the stakeholders, and on the level of risk. And that for us is the key. actually the key point. The value of AI does not come only from building a strong model. It comes from making that model understandable enough to be trusted, to be usable enough to support decisions, and to be adapted enough to fit the real business context.
Yes, exactly. And that is also how we think about our role at Mosaic Factor. We help companies connect technical AI systems with real operational and business needs. So AI can move from an exciting idea into something actually practical and useful. And I think that with that, we would love to open the floor for questions. Burshu, our chief data scientist, will be happy to go deep into technical side or address any question you may have. Thank you very much.
Yes, so let me check. So the first question we have is, how can a company determine when explainability is truly necessary and when it isn't?
Okay. I think we need to start with the fact that even the technical solutions require some kind of honesty. So when Chai appeared, everybody was talking that everything needs it, everything needs at the high level, but the honest answer will be more around like why it is needed and what for it is to be used. So basically, every model will not need the same level of explainability, but if we think more like, let's say that how it's affecting, right? Like impact on people, for example, is it affecting maybe employment? Is it affecting maybe the credit score at the bank? Is it affecting healthcare? Or is it affecting, let's say, the life itself, for example, like in autonomous vehicles, etc. So in these kind of cases, of course, that explainability will not be optional on the table, that it's actually required. And then basically there's also human decision part, where we can say that if a person relying on the model's output to make a consequential decision, meaning that if they need to justify, challenge, or maybe even escalate that decision, they need to understand it first before they actually keep moving on. And there will be also like the regulatory part, where like the sectors like finance, healthcare, insurance, or automotive, explainability requirements are increasingly codified in the regulations. And this is in the European Union, is by the European Union AI Act. And so they actually clarify the fact that it needs to be done. It's not optional, it's mandatory. So we need to provide this kind of information. I think that will be answering the question.
Yes, if not, just write again a follow-up and we'll be happy to address it. So another question we have received is, what are the business risks of deploying AI systems that perform well technically, but cannot be properly explained?
I think this is a generic data science problem, like not the problem, but the problem we have in the domain with some, let's say, data scientists. So once we see that the high accuracy, we think that we did a good job and it's done, right? Like the model accuracy is high, it's perfect, let's move on. But in reality, it's kind of like false sense of security at some point. And so a model that performs well, maybe on historical data, but cannot be interrogated, maybe picking up on patterns that are spurious, biased, or fragile. And we won't know until something goes wrong in production. We will still say that we have a good model, right? And there are actually some business risks there, of course. And one is that this accountability gap. So when, for example, a decision after we put it in the production challenged by a customer or regulator, this is more like the legal side, right? Or auditor. So the model said so won't be enough answer. And even though if it's like with a high accuracy, and it won't be defensible neither. And so then other part will be, as I mentioned, will be the bias blindness part. So unexplainable models can encode and amplify actually historical biases in the ways that are invisible until they are on the production. And this can be very risky, for example, on the road with an automotive, or with the diagnosis, let's say in the healthcare. So these are human lives that we're speaking of. And also maybe the other business risk will be the fragility under the change. So for example, if we don't know how and why a model works, okay, and we won't be able to know when it stops working. So the model drift will go undetected for a very long time, and this will actually cause unreliable outputs at some point. And probably also the other one will be the adoption failure, that, for example, business users who don't understand or trust a recommendation that comes from a model will ignore it, because this is happening in real life production, that after a certain point, let's say that they start to ignore because there's also an expertise that they have, or maybe they trust more on their decision more than the AI decision. So we just need to look for actually a complementary way to move on. But here, if let's say the users will not understand how the model works, it will end up by ignoring the outcome. So this is like the adoption failure. And the last one will be again with the regulatory exposure, because imagine that in an increasing number of sectors, jurisdictions deploying unexplainable AI in high-risk decisions is not just risky, but it will become non-compliant at the end. So it needs to be actually supported in each domain, in each sector, etc.
Okay, let's move on to the next question. What should executive ask before relying on an AI system in an important decision process?
I think this will kind of follow a flow. Like first, for example, in data science, before we start modeling, we try to understand what the data says, right? So we are trying to put a model that will be good with the data that we have, also considering the requirements and limitations or constraints that we have. So it's kind of like a similar approach with maybe a bit differentiated questions. For example, it will start with what decision is this model actually doing, supporting. So it's always starts with a better understanding of the bigger picture, right? So you just like go step by step. So basically what you're looking for is that decision clearly defined, or has scope crept beyond the original intent, etc. So this is kind of like the fundamental thing. And then of course, like they need to think, for example, what would a wrong answer cost to them, right? So it's not only financially, by the way, because consider reputational costs that they can have, or regulatory or human impact, that as we spoke, because sometimes with the high risk AI we have the human at the end that will receive the full impact of the decision. It's not like a lab environment, it's like the real world. And then, of course, like other questions will be that who needs to understand the output? And here, are we speaking of a data scientist as an end user, or a business user, or like the auditor or the regulator? But these are all different types of explanation required due to the technical level changes, because the technical level of a data scientist will not be the same with a public company regulator, for example. But we need to make sure that these decisions, the explained AI decisions, are actually interpretable and understandable by different kind of end users. So this is not only for technical people, this is for the full domain, that we make the better decision together after, of course, the production implementation. And then probably the next one will be about the model validation. So in also what context. So a model validated on historical data may also not reflect the current conditions, so this executives needs to ask, when was actually it last tested against the reality? Was it like a few days back? Was it over a year? And because this model drift issue is something else, so they need to ask these questions about also even already validated models. And then also, like, I think, okay, we talked about the end user, if it's a data scientist, etc. But there are also users, they are not the end users, to look at the explainable AI decisions in detail if it's not a validation purpose, but there are also other users who are receiving some outputs that in their lives. For example, you can be a patient or you can be a driver in a vehicle. For example, like, can we explain this, not maybe all of the decisions, but very important ones to the other kind of end users that are the impact receivers, actually. So, and also like probably the last one will be about the models, if the model is wrong, like, all right, so is there a human review process? Because I think lately what is more important that is noticed also with the European Union AI Act, it's important that we know that we cannot rely human expertise 100%, but we cannot also rely on the AI 100%. So because one mistake will be like causing a lot of problem. So lately we are talking about human in the loop processes. So of course, like it will differ from process to process, scope to scope, but we need to find a way to decrease the risk of AI, even from the executive's perspective, and how much human or how much AI involvement needed for a specific process to be defined. I think these will be the more or less the main risks that the executives should keep in mind, in my opinion.
Okay, right. So let's go then on to another question. How can explainability help our teams use AI recommendations with more confidence in day-to-day decisions?
I think with day-to-day decisions, what it means more like the operational side more than the governance, in my opinion. And generally, like the practical value for frontline teams is significant, but often underestimated as well. And so imagine that when a model recommendation comes with an explanation, okay, and even a simple one like, for example, this customer was flagged primarily due to the payment history or recent account activity or something like that. So here the several things will happen. For example, internal teams can actually do some sanity checks for the reasoning. And this will be about if the explanation will align with their domain knowledge. This is very important because we are human beings, but as our role requires at the companies that we work for, we are there because we have the domain expertise. So we already know things by years, by the education, or with the reality that what's happening in the domain. Plus, we are accompanied by AI together. So that's why like domain knowledge is very important from the teams when they do the sanity checks. And also like the confidence will increase, of course. And if it doesn't, so they will just catch errors that like the errors that the model wouldn't catch itself. And then other thing will happen will be with for the teams that it will be like overriding, means that overrides become informed rather than arbitrary. So for example, without an explanation, human overrides of AI recommendations are essentially guesses, right? So with explanation, they become reasoned judgments more than a guess, and which is both better practice and more defensible, internally and externally defensible we are speaking of. So first you need to actually clarify that it is done in a good way internally to your company, and if you're working with other external clients, also to them. And then of course, like from the team's perspective, the trust will accumulate over time. And for example, when teams repeatedly see that the explanations are consistent and sensible, and the trust in the system will actually be built organically, right? And without that visibility, the trust either never develop or it will be misplaced. As we spoke before, like people will start to ignore it. It's the same thing for the teams. So they need to have a system that they can rely on and also bring their expertise to it. And I think also the last thing we are also like thinking internally is about onboarding processes for the teams. And this is very important. And the new team members can actually understand how the model thinks much faster, okay, when the explanations are part of the workflow. So imagine that internally when you're using it, you're using to validate the work that the team does to your company to prove that you did a proper job, and also like to the clients, but also for the internally, even for the newcomers, that they will be helping a lot to understand everything in a faster way and also a more accurate way, let's say.
Okay, moving on to another question we have here. How should we decide whether an AI system is trustworthy enough to support an important business decision?
Okay, I think to start with, we should highlight the fact that the trustworthiness and explainability are related. They are like in the trustworthy AI, for example, the explainability was put under the trustworthy AI for like more than a year, and but they are not the same thing, right? So because a model can be explainable but still untrustworthy, so let's start from there, that everybody understand the differences by the terms. And in some narrow context, a model can be actually trusted without full explainability even. So it depends on, like we said in the previous questions, I don't remember for which one, but we don't need the same level of explainability everywhere. This is one of the reasons actually to make it trustworthy. It depends on the model, needs, the domain, everything. There are a lot of parameters there. And but there will be different dimensions to assess the trustworthiness that we speak of. One, of course, will be the performance reliability. Can we trust the outputs of the model, right? The performance metrics. And also, if the model actually perform consistently across different populations, because this is very important, or time periods, or also even the edge cases, because edge cases are, we know that they are very rare, but they can be very important. For example, in the automotive context, maybe you won't have a very foggy and icy road or rainy day. It will be maybe very less than 1% of your historical data, but it's very important because you need to train your model on these kind of edge cases and explain the decisions to the regulators, the manufacturers, or like the other legal context, to prove that nobody will die because of the car decision at that moment, because you cannot say that we didn't have enough data for it, enough to train. So the edge cases are very important. And also the explainability itself. So can you understand why it reaches these conclusions, right? And do those reasons make sense to domain experts as well? So you see that we always try to put model and domain expert together to have the final actually validation. And then if the model is flagging the right outcomes for the wrong reasons, for example, it will fail when the conditions change in the future. So this is very important. And of course, like there is another dimension of the trustworthiness we speak of is the validation part. And for example, was the model tested in conditions that reflect real deployment, including adversarial cases, data drifts, or population shifts? So who validated and how independently? These validation conditions are very important. And I think the last one will be again like regulatory or governance oversight, this part. So we always ask the same question from the regulatory perspectives, right? Like, is there a human review process? Is there a human in the loop? And because having a human in the loop doesn't mean that sometimes you make a decision, sometimes it makes a decision. No, it's through a feedback loop. So we put the expertise where the AI happens and then make it better, make it more real world AI, not like a lab AI, right? And then also like a mechanism to detect and correct errors in the production. So a trustworthy system at the end will not be just a trustworthy model, but it's a trustworthy process around the model as well, including the model part.
Perfect, thank you. Moving on to I think we have three more questions. How do we identify which of our AI use cases should include explainability from the start and which ones do not need that level of effort?
Okay, I think this also related to the European Union AI Act as well, like how categorized the AI needs and models are, like high risk, low risk, mid risk, etc. this is still going on. This is still an ongoing work, but there are of course like 2, maybe 3 axis assessments for each use case that you have, so that we need to start with. And then the first axis will be like a consequence severity, like as we say that what is the worst realistic outcome if the model is wrong, let's say, or biased. Score low to high, like like is it very risky? Because for example, you're going with a car and an autonomous vehicle decided to change a lane. This is very risky, like because you can hit someone can hit you can cause an accident, you can I don't know, like, or even cause a chain of accidents, to be honest. So these are like the you need to first score the consequence severity, and then it will be like the human reliance. For example, how much does a human depend on this output to make a decision, right? Versus probably it's being fully automated with easy reversal, score low to high again, like, and then we just find where it stands. But use cases that score high on both sides, okay, like both consequence severity and then the human reliance, need explainability by design from day one and not added later. And for example, as we say that it can be bank example with your credit score, or medical diagnosis, or like fraud investigation, anything can come to your mind. And but the important nuance here is the timing point. So explainability is significantly cheaper and more effective when designed it from the start. Of course, it depends on the use case, but for this high risk level AI, you need to consider from the beginning, because we say that, for example, that for the automotive case, even not only the model, but the data that comes to the model is very important from the training perspective, because you're trying to explain the model behavior, but model relies on the data. Is data fair? Does it include, for example, all the genders, all the nationalities, all the skin colors, everything to be recognized by the image, classified as a correct output? And does it include everyone, or for the diagnosis in the healthcare? So these are very important. And but even for the, I think, the medium stake use cases, the question should be still asked at the design stage, like, do we really need it like now, considering the information in the data set, right? And maybe sometimes that it's not, I mean, you are not going to kill anyone, let's say, but there can be still legal consequences of it if you make a wrong decision, like from the business perspective. And as we say that you can lose your reputation as the developer, but at the same time it can cause a bit like out of legal context, because you're supposed to include everyone, you have to assure the inclusion of every ethnicity, etc. Imagine like this. And but here there's also, I think, this vulnerable population thing is very important lately, in all the domains, especially on the image recognition or the diagnosis parts. And we are still talking time to time that if women, for example, were included enough in the health research for the training data, like historical data, to decide on the medication, or like the surgeries, or even on the car seats, that so these are always like biased historic data. Maybe in the means, like in the historic times, we didn't have the model training on top of this historical data, but we still see that the outcomes of these decisions are still biased. So we need to prevent it in the now digitalized world era, with the AI models, with the data that we have, I don't know, maybe in the last 100 years or 50 years, depends on the sector. But this time we have to make sure that the decision is good for everyone. It's considering everyone, and without any excluding minority group even. And I think this will be the answer from my side.
Right. So I guess what you're saying is that the answer would be doing that through explainability.
Exactly, because we can actually be sure not only about how the model makes the decision, but how the data impacts the decision. So we can actually check both. If your data was biased, then based on this biased data, how the model made the decision. Does it cover this bias issue? Does it recover from it? does it still provide, let's say, fair results, or it relies on the data and cannot figure it out? So these are like two steps, like pre-model, in-model, like, and then in each step, we are actually trying to be sure, thanks to the explainability, that we are not excluding anyone, let's say.
Yeah, that is a very interesting point. And okay, so we have two more. If a company wants to start improving or building trust in its AI systems, what should it prioritize first?
I think it's a bit like similar. First, of course, we always need to identify the highest stakes use cases, like the high risk ones, and where AI is currently influencing decisions that matter most. Is it to customers? Is it to business? Is it to regulators? And we always start from there, not with the most technical, interesting model, but starting to understand the needs. And then we go and define who needs to trust what. Again, like we are putting the fundamental things on the table. And then here, for example, the trust is always actually related to a person and a purpose. So, for example, regulator needs auditability, a business user needs actionable reasoning, etc. But we have to clarify which audience we are building trust with before choosing any method that we start building. But then, as the third phase, we will assess current explainability gap, right? This is what to explainable, where to explainable. For example, for your high stakes use cases, can you currently answer some important questions that you have in mind about the output that you're trying to produce? It can be a recommendation, it can be a classification or regression, doesn't matter. And in the last part, you actually choose the method that fit the model, because we know that there are some model agnostic and model specific techniques. So we are actually trying to choose the model that fits more to the algorithm that we are using, and also the audience. So this is where tools enter the picture, actually. So for interpretable models, the explanation may already be available, but for complex models, like it's a bit tricky, like when it gets more complicated, you also, you realize that it gets more difficult to explain. But in the last part, we build explanation into the workflow, not just the model. So as Mosaic Factor, this is, for example, where we focus. We know that there is a model, but we look at the data as well, because most of the problems are actually coming from the data and then through the model. And you can actually divide into three phases, like pre-model, in-model, and post-model, because people are even like require different kind of explainability after we explain the model. As we spoke, is it a data scientist, or is it a public company manager that they are looking at the same results? So they need different ways to present the output. So we actually, at the end of, we are sure that everybody understands what the model does, how it does. I think it will be it. I cannot come up with another thing, but I think it will be more than enough.
Okay, so let's address the last questions, but of course, if anybody has follow-up questions, just feel free to contact us and we'll be happy to answer at a later time, okay? So the last question is, how do we explain the decisions from AI models to regulators, to auditors, or customers who have no or not enough technical background? Okay, so not enough technical background or not technical background at all.
This is exactly what I was saying, right? So we actually have the output from the explainability, that how the model works, how the decision was made, but to whom we are presenting this decision. So because we are obligated to be sure that the defined end users come with different technical backgrounds will understand what the model, what the chai model will say. So here is kind of like think last mile problem of the chai. And because here we are actually going to explain technically, but at the same time, sometimes to a non-technical person. So it's kind of like a balance there. So I think if we can define some key principles, so we have to lead with the decision, not the model. Okay. Here, for example, regulators and customers actually will not care how sharp values or the other values are computed, right? They need to understand why the model is making this decision, and or they care whether the decision was fair or justified or consistent. This is very important as well. And so the idea is to frame the explanations around the decision and its factors, but not around the model mechanics, because, okay, for a data scientist, it will be important to understand the inner mechanisms, but for a less technical people, it will not be. And so once you provide too many technical explanations to a non-technical user, of course, they will lose their interest, and because they want to understand, it's very simple. And on the other hand, as we spoke before, that we work in the positions we have because we have the domain expertise, right? Because we were educated for it for years, we were in different projects, we understand the context of the domain that we are in. And so for those people, we are going to actually use the language of not data science, even it's a data science issue. We are use the language of the domain that actually they can do this assessment by looking at the results and what they have in their mind because of the expertise. So then they can actually evaluate and do the assessment if they can trust the model or not. It's not only like looking at it and having an objection, but try to understand if the model is right, for example, how they can judge this reasoning. And then, of course, we have to distinguish explanations from the perspective of global versus local. And because the regulators often want to understand overall model behavior and especially potential bias. So this is the legal part that we are speaking of, and this is the important part. But this is the global explanation. So customers want to understand their specific outcome. So then this will be a local explanation, and this requires actually different outputs from the same system. So are you looking at the high level of how the model performs, or look maybe a specific case where the people couldn't get a loan from a bank, for example? So are you providing the explanation only part of it? And of course, there will be another part for the documenting the explanation processes, not just the explanation itself. And for example, the auditors in particular want to see that there is a repeatable and governed process for generating and reviewing explanations, not just that you can produce one on demand. This is also quite crucial. And I think the another thing is that, especially on the health case, this is very important to be honest with the explanation that about the limits of the model. So, for example, we were talking about the edge cases, okay? And the edge cases are very crucial, very important. And if we just give one simple example, let's say about the healthcare, there is a diagnosis process that an AI is implemented, and we are trying to also imagine that the end user may be a specialist, a doctor, etc., that they get the output. That person, the end user, already experienced, has the domain expertise, but AI is there using years data, let's say. But for the edge cases, this is very crucial, because if the model can say, okay, this is the decision, but this is not a very common case, etc., giving enough information to the doctor to attract more information. This is very important, because diagnosis is very crucial, especially from the cancer diagnosis and very important disease such like cancer. And from doctor's perspective, from patient's perspective, also legal perspectives. So there are a lot of aspects there to be fulfilled. But having a model explain the behavior plus its own limitations will be actually a very honest way. And also, when we were saying that sometimes it's not 50-50, the involvement of AI and then the person. So then the doctor will be aware that maybe they need to increase their involvement into such cases instead of relying AI purely in this case. So that will be the balance of having human and AI in the same loop. But this is also why the human expertise is important. but they need to see an honest version of the model in order to be involved and help the decisions, or sometimes intervene if needed. For example, like in manufacture, like now the system is not doing well right now because they are maybe there for 20, 30 years of work. They said that, no, I intervene to the manufacturing processes because this is not going to happen like this, because they already know. And so this will be, I think, my answer.
Okay, so with that, I think we'll wrap it up this first session of the Explainable AI series. Thank you everyone for participating.